Okay guys, so you're welcome back to today mathematics class for this upcoming WAEC JAMB examination. So we are staying on this topic, okay, differentiation on the calculus. Yesterday we discussed about the rules of differentiation, where we stop at the first rule, which is called the sum and the difference rules. Today we are going to be diving into the second rules, that is the chain rules. Now let's dive to it. So guys, if you are just joining my channel for the first time or watch my video for the first time, do it to subscribe, like, also touch the button in case what we have a brand video like this, you definitely be the first one notified. And also share this video with your friend across the social media you belong to, so some people can also belong benefit from this channel, from this video. God bless you guys as I take 1 minute at a time to share this video with your friends, with your friend on social media. God bless you, and I wish you more knowledge, wisdom, understanding in Jesus' name. And this upcoming examination, I wish you success. As you share this video, please keep share this video, and give a like to this video so others can please give a like to this video, okay. If you see this video, I've seen our video or our social platform like TikTok, Facebook page, do it to follow us and like this video, also share with your friend also. God bless you guys as you take 1 minute to share this video with your friends. Okay, let's dive into the business of the day. Let's discuss about chain rules. Okay, in this video, I'm going to be explaining in detail the step-by-step and how to solve question on chain rules, how to identify question on chain rules. We are going to be discussing on it in this particular video. So the next class, which is last class, we discuss about the product and the quotient rules. Now let's dive into the rules. So let's discuss about the chain rules. Okay, when we're talking about differentiation, I explained yesterday. If you missed yesterday's class, I'll drop the link in the description of this video so you can get access to it, or you go to the comment section and ask for the link. So I will direct you to the video where you can get the previous video. And if you're just joining our channel for the first time, you have not yet joined our WhatsApp group. Okay, that is a mentorship group. So if you have interest of joining our mentorship group, you can go to the comment section and comment that you want to join the link for the group. So I will direct you, I'll send the link to you, and I'll direct you get the link. So guys, I'll be waiting for you guys to say there in the group. Let's dive to it. Chain rules. So how do you identify question that this question belongs to chain rules, and how do you solve question that belong to chain rules? So before I go to the example of it under chain rules, let me give you the expression of chain rule. A expression of chain rule is always given that when you have a question, when you have expression that we have a u, okay, let's say we have y is equal to, we have y is equal to, something is missing up here. Okay, we have y is equal to, what happened to this pen? Sorry for that. Okay, we have y, okay, is equal to, okay, let's say we have this part here that we have y is equal to u plus v. Let's put it in that way. Y is equal to u plus v. Now how do we differentiate this? Okay, let's say that it is given as x to the raised power of 2, okay, u plus v is raised power of 2. So what you just have to do here, a question like this is a chain rules, and a expression like this is given as chain rules. Now, how do you solve this question? The first thing you do when you are solving question on that chain rule, because this one has two parts and it is raised power of what of this, you can use a Pascal triangle to solve this question. Okay, but we are not dealing with the Pascal triangle. Let's use normal differentiation to solve this question, to give this expression. When you differentiate this question using chain rules, this is how you differentiate it. You first of all that this bracket, what we have in the bracket here, to be called to a letter. You use to represent a letter. So let's say all this bracket here is represent as let me say represent as t. Okay, let me say all this bracket here is represented as t. So that means t is equal to u plus v. Okay, so since u plus v is equal to t, so therefore our y it will be equal to, y now will be equal to, that is a u, that is t or t square, because of square you have a t square here. Now we have two parts here. The first part is this, and the second part is raised power of 2. Now our y is equal to t raised power of 2, where this t is equal to u plus v. That is quotient true. Now whenever you see the question like this in this aspect, and we're trying to find what the y, okay, the s, you have to differentiate the question with respect to s. What you just have to do here is to expand this was this y the s, to expand it, okay, to expand it with respect of this t, okay. You use this t to expand it of this y du. So how do you expand? What do I mean by you should expand it with respect of this one, of this thing? What you just have to do, in first of all, differentiate this t. So respect to s, so it will be equal to the t, okay, the t divided by the s, the t ds. So you first of all differentiate this t respect to s, multiply by, okay. The second one, you not differentiate the original question. That's y respect to the t, that's equal to the y, okay, respect to the t. So if you look at it now, if you multiply together, this the t, we can't do the t here, we have the y over the s, therefore we get this. So it means that when you can expand this one, it gives us what as this. According to the chain rules, the answer, the expression of chain rules is given like this. When you have something like this, it is what is it in chain rules, or it is called function or function. I get down. So let me try to go space down here so you guys can see it more better. So you can see now. So according to the expression, okay, the general expression for chain rule is equal to dy ds equal to the t ds multiplied by dy dt. Dt is not a constant. It's depending how you use to represent. If I represent m, if I say m is equal to u over this, so it will be equal to this m, okay, over the s, and the y over the m. So if I use m to represent t here, if I say m is equal to this one is because if I say m is equal to this, m is equal to this, so this one becomes the m of the s, the y the m. I get now. So this expression here, it is called chain rules. This expression we have here, it is called chain rules, and the question on chain rules is always in this form. Okay, so let's look at example we have here. If you look at this example we have here, let's use that example to explain it more better. So we have this example here. We say that differentiate a. We have the question a. Y is equal to 2s plus 8 close bracket raised to the power of 4. So we want to differentiate this one with respect to s. Well, so to differentiate this means that we are differentiating with respect to s. That simply means that let's look at the solution. So you have the solution. So this one simply means that we have a y. Okay, let me write y is equal to, that is so what happened to this pen? Sorry for that. So y is equal to, we have open bracket, that is 2 or 2s plus what 8 close bracket raised to the power of 4. Now let's differentiate it with respect to what to s now. So do that, you first of all represent this bracket with a certain letter. Okay, let me represent the bracket here to be equal to certain letter. So let's say the letter is t. So let's say t is equal to 2 or s plus 8. That is the first step you do when you see a question like this, expression like this, and you're trying to differentiate it respect to s. You first of all represent the terms inside the brackets with a certain letter. It can be u, it can be v, it can be z, it can be any letter you like. Just know that that letter is to be useful. Just know that letter to be equal to the thing inside the numbers, inside the data, inside the bracket. Now, since you see that t is equal to this, now this our y now becomes y now becomes now y now becomes, that is this one becomes t is equal to this. So now y now becomes t raised to the power of 4. Now 6t is equal to 2s plus 8. And our t is equal to, our y is equal to 2s plus 8 raised to the power of 4. So that is why y is equal to t raised to the power of 4 is not set here, which simply means that t represents what the bracket we have here. Now let's solve it now. What you just have to do, if this thing to record now is to record the general expression of chain rules, and we have the general expression of chain rules we have here that's equal to, that is a dy, okay, the y ds equal to, we have the t over the s multiplied by, we have the y divided by the s. the t rather, the y divided by what? The t, because we have to differentiate y respect to t. So this one is t. Now, let's solve the problem. Now, the first of all here, you want to find the value of the t ds, and then find the value of the y dt. Differentiate the t with respect to s, differentiate y with respect to t. Now, our t is equal to this, so it means that we want to differentiate this one with respect to s. So let's differentiate with respect to s. We have our t is equal to, let me try to write it out. We have equal to 2 or 2s plus 8. Now let's differentiate is that the t, okay, over the s. So let's differentiate this t with respect to s. Now when we differentiate it now, the s, this place s is principal of 1 here. According to what I explained yesterday, s is principal of 1 here. So it means that we have 1 here, okay. 1 times 2 we still have 2, okay. Now you not subtract 1 according to the general expression here I explained yesterday. You subtract 1 from this, that is minus what? 1, okay. So it means that our s is power 1 minus 1. Now plus, let's differentiate this part, that is 8. S is a constant which does not have any variable s. So it means that I told you that when you differentiate constant is always equal to 0. So this one is called 0. Now you can say therefore, okay, our dt, okay, ds is equal to, now here 1 minus 1, that is equal to what? 0. So it means that s is part of 0. So it will be equal to 2s is part of what? Of 0. And if you remember indices, because this topic and indices, they are work together. So indices, we still remember, anything that is power 0 is always equal to 1. So it means that this one is gives us 1. 1 times 2, that gives us 2. So it means that our dt, okay, so let me try to create space down there so I can solve it down here. So it means that, let me try to run this one up. So it means that our dt, okay, our dt ds is equal to, so since s is equal to s is power 0 is equal to 1, so 1 times 2, that is equal to 2. So our dt ds is equal to 2. So when you differentiate this t respect to s, the answer is equal to 2. See the way I break it down. I hope you guys understand it. So if you understand this, please go to the comment section and let me know. Now let's dive to the second part now. So you have solved this one, the t, the s. So let's solve this one, the y, the t. Now to solve the y, the t, it will be equal to, our y is equal to t raised power of 4. So let me just try to open some bracket here, okay. Let me do a line. So since our y is equal to t raised power of 4, now to differentiate this one, let's get our dy, okay, respect to t. Still need more space there. Yeah, I think we see half. Okay, good. So let's differentiate this respect towards t. So when you differentiate this one respect to t, now this 4 raised power of 4, okay, this 4 will multiply by this base here, that is with 4, okay, multiply by t, that is t, that is 40, and you subtract 1 from this 4, that is 4 minus 1. That was what I did there also. So 4 minus 1, that is 3. So it means that to be equal to, that is 4 t raised power of 3. So which simply means our dy, okay, dt is equal to 4t raised power of what? 4t raised power of 3. That is the version of it. Now, the next thing you have to do here now, you know, to put it into the general expression we have here, then you get your dy ds. Now let's our dt ds, we have it as what? As 2. When our dy dt, we have it as 4t raised power of 3. So let's put it into the general expression we have here. So let me try to create space here so we can do it in that place. Now to be equal to now our dy, okay, let me try to, sorry guys, okay. So let me try to create it now. We have our dy ds, we have the y, okay, ds is equal to, we have the t ds, and the t ds is equal to 2. So we have 2 multiplied by, okay, the t, the y dt, the y dt is what we get as, this. I want to try to show you guys. So it's what we get as 4, okay, 4t raised power of what? Of 3. Now, so let's put it into what we have here. Okay, I think you can get it from this place. Okay, you guys can see it now. So let's put it together. That is multiply dt dy dt, which is equal to this. That's equal to 4. Okay, 4t raised power of 3. 4t raised power of 3. Now 4 times 2 times 4, that is 8. So it means that our dy, okay, the s is equal to 8t raised power of 3. And remember, since we said our t is equal to, for what we have here, t is equal to 2s plus 8. Therefore, let's omit t because t does not give in the question. So let's omit this t from this place and let's replace it by what we have here. T is equal to 2s plus 8. Therefore, our dy, okay, ds, it now becomes, that is 8 into brackets, okay, that is 2 or 2s plus 8, close bracket, raised power of what? Of 3. So when you differentiate this one with respect to s, the answer is equal to this. As simple as that. So this is our final answer, and that is what means by chain rules. That means by chain rules. That is the answer to this question. I hope you guys understand it. So if you understand it, please go to the comment section and say you get it. Okay, I say that if you haven't joined our group right now, maybe you support our WhatsApp support group, so our mentor group. If you haven't joined us now, just go to the comment section and request for the link, so I will direct you to how you can join the platform. Okay, now we have solved the question 1a. So let's move to the question. Let me bring the question 2 outside there. So we have the question 2, that is question b. So if you look at this one, it's similar to this. What's making it different? This one is the square root. Why this one has to power out there? Now, how do we solve a question like this? So let's dive to it. So let's say question B. So we have solved done with this. So let's say question B. We have our y. Our y is equal to, we have the square root of s is power of 2 minus 1. Now, let's quickly solve it. The first thing you have to do here, this is a quotient rule. I'm sorry, this is a chain rule rather. I made a mistake. This is a chain rules. The first thing, you represent this one with a certain letter. Okay, I will still represent it as t. You can represent as u, as v, as any letter you like. Okay, just follow this step. It's all the same step. Now let's say our t. Let me use as t as letter. I love letter t very well. That is t is equal to s raised power of 2 minus 1. Okay, since you say s t is equal to s raised power 2 minus 1, so when you put it here, so this one becomes, sorry, I'm trying to create a space that has been enough. So this one becomes, so now this y, our y now becomes, our y, it becomes, that is square root of what? Of t. Again now if we still remember indices, when you have square root, it means that this t is raised power law of what? Of half. That is the meaning of this square root. It means that this t is raised power law of half. If you still remember from indices, that I told you that indices and this differentiation, they almost working together. Okay, so therefore this one becomes, we have our y is equal to, okay, that is t raised power of 1 over 2. That is the meaning of this half. That is the meaning of this half. Now let's apply the general form of the chain rules. Now to get the chain rules to differentiate with respect to s, it means that we have the y, okay, the s is to be equal to, you first of all differentiate the t with respect to the s, that's equal to the t with respect to the s, multiply by the second one. You have to differentiate this y with respect to t itself, that is called the y, okay, with the t. So that means that this t will cancel this, t will cancel this t here. You have the y ds, though we have our question back. So that is the expression of the y ds is given as this, and this is called what? General form of chain rules. Now let's find this one, the t, the s, and after it we find the y, the t. So here we have our t. So let's differentiate this our t with respect to s. Okay, I think that's not, sorry, try to create a space. Okay, let me try to solve it here. Hope you guys can see from here. Okay, so let me bring it from this part, let me bring it to this place. Okay, let me start the bring for this place. Okay, I think we still have enough space here because, okay, yeah, okay. the screen of this phone is not that clear enough. So let me try to blank this space to create enough space there. I don't want to. Okay, now from this part now, we have said our t is equal to this. So let's differentiate the t. Let me try to say it very well. Okay, yeah. So let's bring the t. Our t is equal to this. So let's differentiate with respect to s. So we have our t. Our t is equal to, that is f raised power of 2 minus 1. So let's differentiate the t with respect to s. That is the t ds. So when you differentiate this one, okay, means that this 2 multiplied by this s, that is 2 or 2 that is 2s. We subtract 1 for this. Okay, that is 2 minus 1. Okay, 2 minus 1, that gives us as 1. And when you differentiate this one, we have minus. Okay, we are differentiating constant. When you are differentiating constant, which a constant means the number that does not afford any letter. So that is always called what? 0 in division. When differentiating constant is always called 0. So 2 minus 1, that is what? 1. Okay, so it means that our dtds is equal to, that is 2s. 2 minus 1 is equal to 1. So it means that s here is first part of 1, which does not visible. When the absence under s here is first part of 1, which does not was visible. So the TDS is equal to 2s. Now let's solve dy dt. Now to get our dy, okay, dy dt, the t is equal to, we have our y to be equal to this, right? Okay, we have our y to be square root of what? Of t, and y is this square root of t is the same thing as t raised power of minus 1. Okay, so let me write it out here. We have our y is equal to, that is t raised power 1 over 2. That's t raised power of half. So let's find let me try to arrow it down. Okay, let's find this dy respect to this t. So in this part, this half we multiply by this base t, that be equal to 1 over t. Okay, multiply by t, that is t. So you have to subtract 1 from this one half. That is a 1 over 2 minus 1. Let's think very carefully. I want to explain something here. It's very, very important. So if you look at this place now, this is t raised power of 1 over 2 minus 1. Now if you bring this one out, let's solve this one. This one part, we have 1 over 2 minus 1. So let's solve it. This one's a fraction. Let's make this one also what? In fraction. And then we find what? The LCM. This is simple mathematics. Let's find the LCM of this. The LCM of 2 and 1 is equal to what? That is 2. Okay? 2 divided by 2, that is 1. Times 1, that is 1. Okay? 1 divided by 2, we have minus. We have the sign minus here. 1 times 2. 1 divided by 2, that is 2. 2 times 1, that is what? That is 2, right? Are you guys now? 1 divided by 2, that is 2. 2 times 1, that is 2. That is, I guess, what? This 2. Now, if we add it together now, that will be equal to 1 minus 2. Okay? That is 1 minus 2, that give us minus what? 1. I get down, that give us minus 1. Because we're subtracting 1 from this 2. Okay? That's not possible because this 2 is bigger than this. That give us minus 1. So we have minus what? 1 over what? Over 2. I get now. Now we have our index now is equal to minus 1 over 2. So therefore our dy dt is equal to, that is 1 over 2, okay, multiplied by t. Its raised power, this t raised power was minus 1 over what? Over 2. I get now. Now this is the derivation of this. And this part, if you still remember indices, you can still break this one and to make it easy. You can also break this one. When you have, especially in this, we have a raised power minus what? N, okay, that's negative inverse. So this one is the same thing as this minus a is this one 1 over, okay, that is a raised power of what? Of n. That is negative inverse. So the same thing will applicable to what we have here. So this one simply means that when you have t, okay, t raised power minus 1 over 2 is the same thing to be equal to, okay. So let me try to create space there. Okay, I don't want to clear any parts there. It's the same thing. We say that we have minus over, okay, we have this minus means that 1 over, okay, here we have t raised power of what? 1 over 2. I get now. So that was the meaning. And this one also, this 1 over 2 is something I find the square root of what? Of t. Now let's back to what we have. Let me back at this part. Let me back to what we have here. So when we have said it as t raised power 1 over 2 is the same thing as what 1 over t raised power what of 2. So therefore our dy, okay, dt is equal to, that is 1 over 2 multiplied by, okay, 1 over, that is t, okay, I get none, t raised power what 1 over 2. I get now. So let me try to create space. I don't want to clean any parts. I think there's no space again. Okay, I'll try to clean some part. There's no space. Where should I clean? Okay, let me clean these parts. Here. So but there's no space again. That is why I want to try to clean these parts. Okay, so we can write it very clear. Okay, now from this place now. From this place, let me try to bring it down here. Let me say the arrow here. We have the arrow, so let me bring it down here. So we have this. Here, it will multiply as this 1 multiplied by 1, and this 2 multiplied by this what? T raised power of half. So it means that therefore our y, okay, the y, the s, the t rather is equal to, that is 1 times 1, that's equal to 1, okay, divided by, and this are 2 times t raised power of 2, that's equal to 2 multiplied by t raised power 1 over 2. And I said that this was square root of 1 over 2 is the same thing as finding the square of what? T raised power 1 over 2 is the same thing as finding the square root of what? Of this t. So this one is almost the same thing as what? As 1 over, that is 2 multiplied by root of t. Which one of this t is this half represent root of t? Now we have get our dy dt as 1 over 2 root t, and our dt, where to solve this one, we have dt ds. Our dt ds is get as what? As 2s. So let's put it into the general expression we have here. So now therefore the answer it will be equal to, we have the y ds is equal to our dt ds is equal to 2s. So we have 2s multiplied by, and in this way we have dt dy, okay, dy dt we get as 1 multiplied, that is 1 over, okay, that is 2 roots of t. I get now. So when you multiply together this 2 here, we cancel this 2 here, so now we remain what? S. Okay, it means s here. S times 1, that's equal to what? S. So it means that our, let me try to cover this place off, that is the y, okay, the s is equal to, that is s t 1 times s, that is 1 times s, that is s divided by, okay, root of what? Of t. Okay, if you still remember, this t is represent as what we have here. T represent s squared minus 1. So let's put it here, s squared minus 1, then we get our final answer. Therefore it will be equal to, we have s over, okay, roots of that is s minus s is power 2 minus 1. So that is the answer. So means that divide s, the answer is equal to s over square root of s raised power of square root of s squared minus 1. This is the answer, and that is how you solve this question like this. So the solution to this problem, question B, the answer is equal to this. That is the step by step to solve question on the chain rules, and that is how we solve a question that's similar to this, and that's how we solve a question that's similar to this. That is the reason why I bring you 2 questions. Okay, no matter that we set a question, they don't set a question that is that's beyond this. Okay, that's a question that's beyond it, because I'm trying to explain it step by step. That is why it take long like this. Okay, if I were to be the one that I understand this step now, you can solve it within 1 minute. You can solve within 1 minute. Okay, if you follow me step by step, you can solve it within what? 1 minute. Now that you have understood it, now what you just have to do here, I have a classwork for you to be submitted. Is very important. You know that my class, I always give you classwork. Okay, that is very, very important. This classwork will make me know that you guys, you are well attend the class and you have understand the class. So when you solve the question and you find that there's an issue, you don't get the answer, come to my DM. Okay, send what you have did. I'll check the where you made a mistake, so I will be able to correct you. Okay, so I'll be able to correct you. So if you are still not yet joined our support WhatsApp group, so you can contact me on this number now. I want to write on the screen now. We have 09060, sorry, it is my right here, 090, okay, 61 22, that is 1656. Okay, join us now. It's still free when you join us today. Okay, it is free. Our support group is free when you have the intention to join us today. Send a message on WhatsApp and submit the classwork. Submit the classwork. Okay, submit the classwork, and I will make the correction. If you don't get the question right, I will do the correction for you. Then I will explain it for you. So guys, thank you, and don't forget to follow us and share this video with your friend and family. God bless you as you do so. Bye. Let's meet in the next class for the product and the question tool. Bye for now. Make sure you submit the assignment. It is 2 assignments. We have the first one. It is 2 assignments. If you look at very well, we have the first one, okay, and we have the second one. Here is 2 assignments. Very important to submit. Okay, guys. Bye for now.